Okay, we're looking at mixed exercise 7 from the first year core textbook, and we're on question 9. So we've got an exam question, which is good because we can see how many marks each bit's worth. And we're also told it's a bit of a problem solving one. So, okay, so as long as you're happy with what this notation means, part A is actually really not too bad. So that means that when you substitute -1 into this function, you should get another sort of 0 out. So let's write that down. So if I substitute -1, so I'm substituting -1 into this. So it's going to be -1 e cubed plus 4 times -1 squared plus r times -1 plus s. And that should give me an answer of 0. So let's tidy that up. So -1 all cubed is just -1. -1 squared will be 1. So that'll be plus 4, and then r times -1 plus s is 0. So 3 minus r plus s is 0. And I won't bother rearranging that anymore until I've got my second equation, and then I can decide how I want to do it. So this then is saying when I substitute in 2, I should get an answer of 30. So we'll do the same thing again. So if I substitute 2 in, I get, so it'll be 2 cubed plus 4 times 2 squared plus r times 2 plus s, and that should equal 30. So 8 plus 60 plus 2r plus s equals 30. So let's collect all our constants together. On the right hand side, so 8 plus 16 is 24. So if I take that away from the 30, that will equal 6. So I will now be able to find r and s because I've got 2 equations and 2 unknowns. So really it's just deciding how I want to solve the simultaneous equations. I think what I'm going to do is I'm going to leave the second one as it is. I'm going to rearrange this one slightly in that I'm going to minus the 3. And then I'm going to do the top one subtract the bottom. So 2r minus r is 3r. S minus s is cancelling. 6 minus -3 is 9. So r is 3. But there's lots of alternatives you might have used. You might have made r the subject or made s the subject of each of them. You might have made r the subject of this one and substituted in for this one. There are lots of slight variations on that. Okay, so then I need to find s. So I'm going to use that one because it hasn't got any negatives in it. So if r is 3, 2r is 6, plus s is 6. So I'm just thinking ahead there. Okay, so we're going to end up with s is 0. Now that can be a bit off-putting, make you panic that you've gone wrong. But actually, if I check this one, yeah, s would be 0 from that one. And if we go back to the original question, there is no reason why s can't be 0. So it just means that there is no constant. So, the full cubic is x of h is x cubed plus 4x squared plus rx plus s, which is 0. So there's no problem with that. There's no reason why it has to have a constant. So I've got my answers to A highlighted in green there. Okay, and then so hence factorise. Well, this actually is very helpful because I'm factorising that cubic. So the first thing I would definitely do is just take out a common factor of x. Okay, so then actually all I've got to do is factorise that quadratic if it factorises. Now, in fact, I know it does factorise because of this. So this was actually factor theorem, wasn't it? If you substitute in -1, you get 0. So that does tell me that x plus 1 is a factor. If you didn't spot that, it really wouldn't matter as long as you can factorise this quadratic. So that quadratic factorises to x plus 1, x plus 3. Okay, and that is fully factorised. Let's just double check anything daft. X plus 1, x plus 3. Nope, we're good yet, and s was 0.